Hi, and welcome to question 8 of the Leaving Cert Ordinary Level, Paper 2 from 2021. So, as always, if you want to copy the set notes I'm working off, just send me an email at shanetroy@gmail.com. That email address should be in the description below. And if you like these videos, just click subscribe to get access to more playlists. So, let's get stuck in. So, this is the second question of section B, one of the longer questions. And as these questions usually are, lots of text, so don't be afraid to read these multiple times to figure out what's going on. So we have some sort of shape here, and like I can tell which question this is already. But let's get stuck in and see what it is. So it says here the diagram on the right shows the plan of a lake. Okay, so this is a lake. The line segment PQ represents the distance from the pier, so this place here, to the far side of the lake. And they're calling that Q. Okay, and equal intervals of 10 meters. So it's 10 here, it's 10, 10, 10, 10, 10. Okay, so fair enough. In equal intervals of 10 meters along this line, perpendicular measures are made to the sides of the lake as shown. So it's just showing you the distance from the central line to the lake at 10-meter intervals. So we know a lot about this particular shape. Now it's worth pointing out that this is an irregular shape. So if we've been asked to find the area, which look, I can see down here we are, it's going to be a little bit harder than what we would normally be dealing with a regular shape, which would have a formula attached to it. Now with irregular shapes, we do have a formula, okay, and the area, this is what the trapezoidal rule is approximately equal to, because it is an estimate, it's not an exact area. And it's the interval divided by 2, all multiplied by the first plus the last plus 2 times, now this sounds terrible, everything else. Okay, and that's close brackets. Now there's a way of saying you can say y1 plus yn plus 2 times y dot at 1 dot, no, 2 dot 3 dot 4, whatever. Okay, but I think this is more easily able to be remembered. Now the trapezoid rule is given in the math tables, but it's given in that more complicated version. Now in this formula, okay, I'm looking for the area. I need to know everything else. Okay, as in the h, the first, the last. Now if I start, well, this is my h. Okay, this is my first, second, third. This is fourth, fifth, sixth, and this is last. So I do know lots. Now the h over 2 there is, the h is 10 over 2 times the first. Now the first length there is only 10. Okay, you could do this as 2 separate segments if you wanted to, but I think it's better off doing it in one go. 10 plus, now the last, there's no difference here, so it's 0. Plus 2 times, now everything else is, this one here is 20 plus 20, which is 40, plus, now here 10 and 20, okay, is 30, plus this big one here is 30 plus 20, which is 50, plus this one here is 30 and 10, which is 40, plus, now the second last, 20 plus 20, which is 40. So that's the interval over 2, so the h over 2, times the first plus the last plus twice everything else. Now that's a calculator job. I'm going to go straight to the answer here. And I would use a calculator for this. That's what it's for. As long as you put in the brackets carefully. You have a bracket there that's being multiplied, and that's 2 times. And you could break it down by segment, do inside the brackets and move out. But the calculator can handle it if you know how to program it properly. If you do, you're going to get to the answer of 2050. And the units there, because they're area, it's meters squared. Because the units we're talking about here are meters, as it says all the way throughout the question. And that's question 8, part A, part 1. Now, question 8, part A, part 2, okay, says if the lake is on average 8 meters deep, estimate the volume of water in the lake. Now, let's see if I have the area of a rectangle, it'd be length by breadth. What's the volume? Okay, it's the length by breadth by height. Okay, so same thing here. The area of the lake, now we know it's equal to 2050. The volume, okay, is the area times the height. Now put numbers to that. The area we said there was 2050, and the height we're told is 8. Put that through your calculator, you're going to get an answer in and around 16,400. Now the units here are meters cubed, okay, because the area is meters squared times meters, just like x squared times x would be x to the power 3. That's m to the power 3, so meters cubed. And that's it, okay. Now, I think I said this in a previous question, but let's say you were bog, couldn't do part 1 for the life of you. Just, it's not clicking, you can't get it. You know it's an area, you know you need a part for part 2. Make up an answer. Nice round number, it could be 1, okay. As long as you declare that, it's obvious that the answer to part A, part 1 is, let's say, 1. Then if you use that in part 2, it'll be accepted as fully correct. And if you do know how to do part 2, then you can just do it and you'll get full marks for part 2. Don't forget it's a handy thing in certain situations where the questions are linked one after the other. Now, that's that one. So question 8, part B, part 1 says calculate the volume in centimeters cubed of a hemisphere of radius 21 centimeters. And they give you a diagram there and give you an answer in terms of pi. Now, this is where I go to the maths tables, and I don't actually have them open, although I should get them open. And I just pause the video there for a second to try to get them open. So this is the digital version of the maths tables. If I click on the contents, I'm looking here for area volume. Okay, and there we are. So surface area volume. So I'm looking for what is this shape? It's not a cylinder. It's not a cone. Okay, it's a sphere. And they say hemisphere. Okay, so my volume. Okay, let me go back to the actual question itself. My volume, okay, is what was it there? 4 over 3 pi r cubed. So make sure you copy that down. Now you won't get marks for just writing that down because you're given the formula in the mass tables. Now if I did one thing, okay, I want half the volume, okay, because it's a hemisphere, so that's half times 4 over 3 pi r cubed. Now half by 4/3 is the same thing as 2/3. Half of 4/3 is 2/3 pi r cubed. That's my formula. Now it says give me an answer in terms of pi, so don't substitute a number for pi, leave it as pi the symbol. And I haven't said this already in this video, but pi is just a number. It's a long number, it's irrational, goes on forever, never repeats, but it's just a number. Instead of having to write down a number that never ends, which is impossible, we just use a symbol. And just something I just recently, this is a curiosity to me, I always wonder where the letter pi, why was that chosen? Why not anything else? And it was saying that in Greek, where the pi was discovered, I suppose, or the first place we recognize was discovered, the first letter of perimeter is pi. First letter of circumference of a circle is the Greek letter pi, and they think that's why it was used. I don't even know if it's true or not, but it's interesting. Anyway, if I put numbers in, so 2 over 3 times pi, now we were told that the radius is 21, okay, and that's cubed. Now I'm going to go with the answer here where it's prettier. So I have the volume of a sphere. I found the volume of the hemisphere. Now I multiply it by half, which is one way of doing it. If you get half the volume, you have to get half the other side too. That's one of the fundamental rules of algebra. Once I have my formula, okay, I put my radius in, the only value I have, then I didn't use the calculator to convert pi to a decimal. I left it as pi. So 2/3 times 21 to the power 3 is 6174 times pi, and then I put the units in, which are centimeters cubed, okay, because it's a volume. And that's that. Now if I go back to the previous page, I don't want to necessarily get the answer here. So as it says here in part 2, a buoy on the lake is in the shape of a hemisphere of radius 21, surmounted by a cone. Now, I know that this was 6174 pi centimeters cubed, the volume of that hemisphere. Even writing that on the diagram there or making it obvious that I know that from part 1 gets me an attempt, if that's how I call the scheme. The volume of the cone is equal to the volume of the hemisphere. Okay, so this cone here is the same volume as this hemisphere here. It says then find h, the total height of the buoy. Now, we're dealing with basically with a cone, okay? Now, the formula for volume of a cone, let me go and get that here, is 1/3 pi r squared h. Okay, so volume is equal to 1/3 pi r squared h. Now, we know that the volume of that is equal to the volume of the hemisphere, okay, which was 6174 pi. And they're equal. So therefore I can write them equal to each other. Okay, equals to 6174 pi. Now the first thing I see there, if I'm sure they're equal and I want to simplify it, well, if something's common both sides, it's straight away it's gone. So it's 1/3 r squared h is equal to 6174. I could go through the why that is, but you will get there. It's a simple way to do algebra. If something's common to both sides, just get rid of it. Okay, and that's usually what you need to do. But ultimately, we're always trying to simplify an answer down to its simplest form. Now, if you recall there, we were told the radius is 21. Okay, so this equation has two unknowns, but now that I realize that the radius is 21, I now go down to one unknown. Okay, an equation of one unknown is solvable. It's just a matter of solving it. Now, one way to deal with this algebraically is, look, if I realize I need to get rid of this, that chunk of numbers is getting in the way. I want h on its own. The simplest way to get rid of something algebraically is to divide it by itself. Looks weird what I'm doing. And I'm wrong. I've unbalanced the equation unless I do the exact same thing to the far side. Now, what's the consequence of this? Anything divided by itself cancels. It gives you an answer of 1. So straight away, that's gone. Okay. Now on the far side, so let me get rid of that. On the far side, this is a calculation. 6174 divided by 1/3 times 21 squared. Like it sounds really weird to say it, okay? But if I put that in the calculator, that's a fraction, so 6174 on top. On the bottom now I have a fraction here, 1/3 times 21 close brackets squared. Okay, so the calculator was going to do the heavy lifting for me here. Put it through, I got an answer of 42. So my height, okay, is equal to 42. The units there is the length, it's centimeters. And that's it. Okay. So if you see there, that's the same basic chunk of work I've just done on the far side. Okay. Now, I've also just realized I didn't answer the question fully. I got the height of the cone, and I've just realized that it's saying find the total height of the buoy. Okay. Now, the total height, the 42 is this bit. Okay. So that's 42, which I found the height of the cone. Okay. If I want to find the next bit, this is not to scale, but that's the radius 21. So it's 21 here as well. It's 21 everywhere. Now it doesn't look like it because it doesn't look like a sphere because I've stretched it. Okay. So the full length is the 42 plus the 21. That gives me 63. And I've shown that down here. Now probably shouldn't have used the H here. I just realized when reading this question that the H here and the H here are not the same thing. It might be confusing. Maybe you should use a different symbol. As long as I know what I'm doing, it's not a problem. But just when I read the question right now, this second, I didn't actually notice this when I was doing the marking. That was a potential problem. When I'm doing it on my own, do I see that? Anyway, it's not a big deal. So that's 8B. Next one now is 8C. Okay, so it's a long question. This chunk here is worth 15 marks. I see a hint given up here, but we'll get there. Part C says, actually, before we even do that, this is the same lake as we had in the beginning. And you have, within that lake, you have a triangle. The first thing I know is that this is not right angled. Okay. At least it doesn't look like it. Am I being told it is? If it's not right angled, okay, it's going to be either the sine rule or the cosine rule. And I see now why the hint is there for myself. So let's read it. The buoy is situated at B. So that's the thing we just found. That's 43 meters from the pier, okay, 26 meters from the point Q, and then they give you the whole length across here, which is 60. If you recall, I just realized this now, we were told that already. Just 10 plus 10 plus, yeah, 60. That, if they were being real tricky, they mightn't tell you that 60 and expect you to make the leap that it was given to you, but not directly given to you. The leap generally isn't tricky like that anymore, but look, you never know. It then says find the angle QBP. And that's what means there is the B is what's important. Find this angle here. Give your answer to 2 dozen places. So look, I would try sine rule first. The sine rule is A over sine A is equal to B over sine B. So there's 4 unknowns here. If I know 3 of the 4 things, I can use the algebra to find the missing thing. So if I sit here, look, I'm going to call this angle A. I'm going to call this side A. Now I have 2 other sides, so I could call this B and this angle B. So if I look at it, do I have the side A? I do. Do I have the angle A? No. Do I have side B? I do. Do I have angle B? No. So I only have 2 of the 4 unknowns. It won't work. Sine rule is not applicable here. Now, then I would go on to the cosine rule. Okay, so let's write that out. So it's A squared is equal to B squared plus C squared minus 2 times B times C times cos A. Now there's 1, 2, 3, and then the A. There's 4 unknowns. Now the B and C occur twice, but there's 4 different unknowns. I need to know 3 of these unknowns to find the missing thing. It's asking me for the angle, which is kind of in a weird place. It's on its own here. Ultimately, do I have all 3 sides, A, B, C? You see it, I do. Okay, as long as I remember that this 60 has to be A, because it's across from the angle A. It doesn't matter if I call this B or this B. It doesn't matter. Okay, I'm going to call that B, and I've already called it B, and I'm going to call this C. Now you have 2 choices here. You could come along and put in, instead of A, put 60, instead of B, put 43, instead of C, put 26, and then the same thing again, 43 times 26 times cos A. Now that there, if I recall the marking scheme, got you the 11 marks. Because at this stage, you're maybe the 7. I'd have to go back and look at it again. But whatever, you've got a chunk of marks. Because you've shown, you understand this is a triangle, that the cosine rule might work. You've inputted the numbers correctly. And if you stop for some reason, I'd be curious, like, why did you stop? It's just a matter of continuing on. Okay. Now, that's one way of doing this. Okay. I'm going to come over here to the far side. And I'm going to tidy this up here. And this is not necessarily something you have to do. You could manipulate the numbers on the far side. But for the simplicity here, and that's supposed to be a C, if I want A on its own, I should move everything, rearrange this equation to get my unknown on its own. That's what we'd often prescribe to do if you're doing a calculation. Instead of putting numbers in and then manipulating numbers, manipulate the letters and then put the numbers in, then hit the calculator and use it and get your answer. Now here, if I look at it, I want A to stay where it is. How do I get rid of the B squared? Well, the classic way would be to take B squared away. If I have an apple and I take an apple away from you, you've no apple. Now, if I do the same thing for C, okay, I'm okay algebraically to do this, as long as I do it to both sides. So on the left-hand side, I must take away B squared and C squared to be correct. Now, nothing's going to happen there, except I've added in letters. But on the far side, on the right-hand side, they cancel. And you're left with minus 2 times B times C times cos A. Now, depending on how you want to approach this, okay, if I want to get rid of the minus 2BC, again, I want A on its own, so that's going to get me a bit more on the way. The simple way to get rid of something that's been multiplied is to divide it by the same thing. So if I multiply the right by minus 2 times B times C, they're going to cancel. Now, I'm wrong unless I do this to both sides. So on the far side, I'm dividing that by minus 2 times B times C. Then they cancel, and I'm left with A squared minus B squared minus C squared, all divided by minus 2 times B times C, so a handful, equals cos A. Now, I'm almost there. And the way to, I suppose, get rid of cos, because again, you want A on its own, is to move the cos across the equal. Now, what happens when you do that? Okay, if you move something across the equal, it becomes the opposite. The opposite of cos is inverse cos, okay, of everything on the far side. Now I have a formula, okay? I can put my A, my B, my C in, and here again, put through the calculator, get inverse cos of that number. And again, that is just a number. It's just a really complicated number. in the sense that it's going to take us time to get there to see what the actual number is. But it is a number. And inverse cos of a number gets you the angle, and then you have your answer. So if I go back here, so I've kind of done that here in the notes by moving things by hand. Okay. Now the big problem I generally see with this, the mistake that people often make is when they're moving this minus 2 BC across the equal, it goes across and becomes added on the far side. And they forget that this is being multiplied. So when you move a multiplication across the equal, it changes operator to its opposite. In that situation, the opposite of multiplication is division. So that's why it divides. And that's what's happening down here. I think it's easier to do that with letters than it is to do with numbers. Now, if the numbers are whole numbers, it's not so hard. If they're decimals, it can get bloody awkward. And the mistake I used to make when I did my leaving cert was I lived in the time of things were kind of calculator heavy, and I'd round. I'd just start rounding to 4 different places for some unknown reason. I don't know why I did it, but this is maybe I thought I was being right. All I was doing was compounding error every time I rounded something, and my answer would always be kind of different than anybody else's. I just thought it was I don't know what I thought. And that was the reason. It was my fault. I was rounding too early. That mightn't always be a problem. It mightn't be a problem in this particular question, but just as I thought of it. Now I think that's the end of question 8. Okay, and it is. So look, it's a long old question. It's challenging, but if you keep your algebra tight and you use the formulas given, you can be fairly good in terms of result from marks in that question, in my opinion. So anyway, question 8, if you want to copy the notes I'm working on, just send me an email at shanetroy@gmail.com. And if you like these videos, just click the subscribe button to get access to more playlists. Thanks.